welcome to the second episode of the Blockchain Beginner series. Today we're going to be explaining functions and all the different types of things you could do with them. So first, over here we won't be needing anything except the uint. So delete all of this, leaving just the uint. So one thing I wanted to mention was, let's say we did not want to initialize a fave number. Let's say we didn't want to set it equal to anything. First of all, this is as if we're saying equals to 0 or the null number. So I'll leave that as this, and you can write a note above it saying auto sets to 0. Okay, now let's say we wanted to find a way to change favorite number. If you've coded any language before, you know of something called functions. And to define a function, like most coding languages, you write the keyword function. And then you have to give it a name. This could be whatever you want. Let's just say change number. And then following this directly, we'll have open and close parentheses. So now in this parentheses, we add any sort of information we want to give this function or parameters. But one thing that's special about Solidity is you need to define what those parameters are. Let's say I wanted to use a uint, which is what I'll be using here. I'd say uint 256, and then I'd give it a name. So let's call it underscore fave number. So you might be wondering, why did I call it underscore fave number? So in Solidity, it's common practice to always put underscore before the name of the variable that you're about to change. In this case, you have a uint 256 called favorite number. So what we did is we added a underscore before it. Now after we defined visibility, which I'll speak more in depth in a bit. However, for now I'll just set it to public, and then you open and close curly brackets, like most coding languages. And then when you click enter, anything you write inside these curly brackets will happen in this function. So let's say we wanted to change favorite number and set it equal to underscore favorite number. What we just say is favorite number equals underscore favorite number. And obviously ending it with a semicolon, because like we said, that's something you need to write in front of most lines. Now I'll click Command S, which you'll see me do most of the times now, which basically means I'm coming here and I'm clicking this. However, using the shortcut Command or Control S. So now we've compiled it, and I'll be explaining the deploy and run transactions tab now. So first thing, let's talk about the environment. So you have many options here. First thing you have is a JavaScript VM. Now London or Berlin, ignore that for now. However, what does JavaScript VM mean? So basically, there are many different blockchains. If you were to use a real blockchain or a mainnet, you'd be spending gas fees for every transaction or contract deployment. And that would get really costly over time. So other options are testnets or JavaScript virtual machines, which is what VM stands for. So here you have many options. If you clicked injected Web3, let's say you would be using a mainnet or a testnet. However, we won't be speaking about this now. Neither the other options. We'll be speaking about a JavaScript VM. So click on it, and let's click on accounts. Just to show you, now you have a ton of different accounts. And as you've seen, you have 100 ether. Now obviously this is only test ether. And each one has separate addresses. So let's say you wanted to test out different contracts that need different users. This is how you test it. So why exactly would we use a JavaScript VM? If we have testnets, which are basically fake blockchains. Let's say you wanted to run a transaction on a testnet. It would still take time and it's not instant. And as a developer, that would be really annoying because it would take time for you to test everything. So now here, let's say I wanted to deploy this contract. Let's say I click deploy. It instantly deploys. And as you've seen, the transaction has instantly run instead of waiting. So these other parameters here, we won't worry about too much. Gas limit, usually we do not change. And value is if, let's say you wanted to push in a value to the contract, which we'll speak about more in depth later when we're speaking about functions that are payable. So now let's scroll down here to a section called deployed contracts. So I don't know if you've seen me when I did it, but when you click deploy, this contract will pop up here. Let me do that again. So you choose the contract, hit deploy, and this will pop up right here. So now when we go down here and click on the arrow, all our functions would show. But before I speak about the function, I want to speak about this right here. So let me enlarge the screen a bit. Here you get information about all transactions you do. So let's click on this for a second. And let's see what they're trying to tell us. First of all, you get a transaction hash. This will hold all the information about the transaction you've done. And as you've seen, this is very similar to doing a transaction in MetaMask, because basically deploying a contract is also a transaction. As you see, there's a gas fee and most of the other things you have on a transaction. One thing to keep in mind is that anything you do on the blockchain will be a transaction and cost gas fees, except for view functions, which we'll speak about in a bit. So right now, let's say I came here and I clicked and I said my favorite number is 10. Let's say I click change number. As you see, a new transaction happens. Let's open it. You see there's gas cost. This is 50,000 and this is 117,000. So as you see, the deploying of the contract is more expensive than this. However, what defines gas fee cost? It's all in the computation. So let's say I came back here and I said fave number equals to underscore fave number plus 1. And let's say I kept on doing this. So I duplicated this line. One second. I duplicated this line twice and I changed this to 2, this one to 3. So as you see here, we do a lot of computations. We're changing fave number 4 times. So let's X this out and hit deploy. Oh, my bad, we have to compile first. But let's say we hit deploy. Let's open this. Click set my favorite number to 10. Hit change number. Now when we open this, the gas cost is 51,320. If you see the previous transaction, it's 50,000. So basically what I'm trying to show you guys is gas cost completely depends on the number of computation, or in other words, number of functions you're trying to run. So let's revert this back, compile, exit out and deploy again. And let's go back here. So let's say I set it to 10 again. However, how can I see what the favorite number is? For this, we have to set the favorite number to public. So let's put it public, compile, deploy again. And now you see there's a new option here. So let's say I click it. What do you think is going to be the number once I click it? Leave your answer in the comment down below. I'll give you 3 seconds. 3, 2, 1. It's 0. Obviously, because like we said, it auto sets to 0, or that's the null value of a uint. So now let's say I clicked here and I put 10 and I hit the orange button. And then now when I click fave number, it shows 10. And if you change this to whatever you want, 8, it shows 8. You put 7, it shows 7. So basically what's happening now is you're setting this to public. But why didn't we see this when it was like that? What does it get set to when we do not define visibility? It gets set to something known as internal. So what is this? What is public? What is private? I'll be explaining them now. So public is visible externally and internally. So in other words, public is the one with the most visibility. Anyone can see from anywhere. Private, on the other hand, is only visible in the current contract. So let's say I set this to private. Your whole contract, like this functions, could use it. So if we compiled, we won't have any error. However, if you were trying to call fave number from a different smart contract, which we'll take about later, it would not work because it's set to private. Let's put that back to public now. Compile it. So the next one is external. This is only visible externally. So let's say you set this to external. Your own function cannot call it, and only external smart contracts can. Let's say I compiled. Oh, we got an error. It's set to external, but it's trying to be used here. So let's change that back to public and compile. Next, we have internal, which is what it's automatically set to. And this means it's only visible internally. So anywhere in your own smart contract, you could see fave number. However, outside, it's not visible. And now before I move on, I want to speak about something really quick, and that is it's known as scope. So what this means is, let's say I define this right here. I was able to call it from here and from anywhere else. But let's say I was to define a uint 256 here. Let's call it number, and it's equal to 7. Do you think I could call this from outside this function? Let's see. Let's say I made a function called number, same number as that, give it no parameters, make it public, and then let's say number equals to 10. Let's compile. Oh, there's an error. What does it say? Expression, or sorry. You see, we have multiple errors. What are they trying to tell us? First of all, this is undefined. So the reason they tell us all these errors is because they don't know the type, they don't know anything or any information about this number. So let's erase this and remove uint56 number because we won't be using them. And let's be speaking about a different function. So what is basically happening when we say public over here? What's basically happening is it's set to a view function. So let's try to replicate putting public in front or before fav number. So we'll say function again. We'll give it a name. Let's say get number. It will take in no parameters. However, here we're gonna say view. And another keyword you need to use is returns. So here you need to define what will it return. A string, a uint, an int. So obviously for us it's going to be a uint 256. Let's hit enter. And then in here we're going to write return fav number. Let's compile this and deploy. And let's see what happens. So when I click it, it returns favorite number. And let's say I set it to 10. It will return 10. Well, let's see the error here. Oh, obviously we didn't set visibility. Let's set it to public. But that doesn't really matter right now. So anyways, one thing you might have noticed is favorite number is blue, or the view function is blue. However, the other function is orange. So what does this mean? It all depends on gas cost. So remember before when we said all computation or more computation will cost more gas? There's also another rule for the blockchain. Whenever you change the state of the blockchain, it will cost gas. However, for a view function, are we really changing the state? We aren't changing favorite number, we're just trying to see what it is. So for view functions, you do not pay gas. And it's clearly shown here. So as you've seen with the orange functions, there's a green check, there's a hash, there's a bunch of info. However, for this, there's no, and there's way less info. However, let's stop here for a minute. It says 23,493 gas. I thought we just said that view functions have cost no gas. But as you read here, it says cost only applied when called by a contract. So let's say a user wanted to see this favorite number, they can. But if you were to use it outside this contract from a different contract, it would still cost gas. So mainly, no gas functions are going to be one of two things, either view or pure. In both of these, you cannot change the state of the blockchain like we mentioned. So I cannot come here and say fav number equals to 10 and then compile, because it will say it's set to view. So let me get rid of that and compile. But now let's talk about pure. Pure, you cannot change the state of the blockchain, neither get data, which is basically what view is. View gets data. So how would you use pure? Let's say you said, let's make it right now. We'll call it pure function. To take in no parameters, we'll say public pure returns. Let's also make it a uint 56. And then in here we'll say return, just like before, but in parentheses we'll say 1 plus 1. Oh, my bad. So when exactly is this useful? As you've seen, I've compiled and we got no errors. It's useful when you have a certain algorithm or certain computations you want to do or calculations, and you want to do it in one function so you can call it from others. So that's it for today. And I'll see you guys in the next episode where we'll be explaining more about functions and starting to implement simple storage. Okay, and one last thing. For you guys' assignment, I want you to replicate all of this, however, change it in your own way. For example, I want you to have favorite number, however, when you change the number, it will equal to whatever you input plus 10, and obviously you should write a return function. Try to do this without referring to this video. However, if you feel any errors or you feel like it's hard for you, return to this video, rewatch it, relearn, and try to implement it again. However, it's really crucial to try to implement all these functions without referring back to the video. That's the best way to learn. So I recap, your assignment is to recreate all this. However, any favorite number you input will be increased by 10.